Time for a look at the multi-exit discriminator, or as we like to call it, the MED. It's one of these things, you mention the MED so often, people forget what it stands for, but again, the name, it's kind of the recipe, and it's an optional BGP attribute. You're not going to use this every single time or set it every single time. A couple tricky things about it, especially when it comes to setting the multi-exit discriminator value. We're going to see all that on the live equipment. But let's take a look at this lab that we're going to run. And I already have the adjacencies in place. I've tested those, and we've got a couple of routes advertised. I know you know how to do that, so I didn't want to take time up here on the screen going through that again. But please note that we're not using the frame cloud in this lab. We have direct connections between routers 1 and 3, direct connections between routers 2 and 3, and routers 1, 2, and 4 are sharing an Ethernet segment. Routers 1 and 3, 172.12.13.0/24. Routers 2 and 3, that direct connection is 172.12.23.0/24. And the shared Ethernet by routers 1, 2, and 4, 172.12.124.0. And you see that there are a couple of IBGP adjacencies between routers 1 and 4 and then routers 2 and 4. They're in AS124. Whew. All right, now router 3 obviously has two paths it can use to enter AS124. And there may be times where you want one path in particular to be used for all the routes or all the traffic, the BGP traffic. And the thing is, of course, that BGP best path selection, it may not give us the path selection we want. We need to be able to fine tune that. You also may have times, as we're going to do in this lab, where you want traffic for one network to go over one path and traffic for the other network to go over another path. So to practice that, of course, we got to have a couple of networks. So on top of the adjacencies that I've already created for us, I've created two networks. We're using router 4's loopbacks 4444 and 44444, and I've already advertised those into BGP. We've seen all of that in previous labs, so I didn't want to take another 10 minutes getting all that set up here. Now let's go ahead and verify that I know what I'm doing. Router 3, we've got show IP BGP, and you can see we have two entries for each one of the networks as we expect. One of the next hops is going to be 13.1, the other is going to be 23.2, and that of course is true for both paths. Now notice that all the paths are valid, and the paths that have been selected as best, both routes are going to use the 13.1 path, the path through router 1. And why is that? We got that list down now. We do have the list down now, right? That best path selection. Well, first off, we see there's no accessibility issue, so we love that. We see valid, we see external, we see the same local pref. That's the default value for local pref 100. We don't see anything mentioned here about a MED. And again, that's because it's optional and we haven't created it yet, so there's no metric to tell us about. And it turns out that the deciding factor ended up being the BGP RID of the routers. And one's was considered superior to two. It was lower. So you can see best, you see 172.12.124.2 and 172.12.124.1. Well, that might work for us. Maybe that's the path we want it to take. But then again, maybe it's not. And maybe both of these paths are going to be so heavily used that we want to split the traffic up a little bit. So that's what we're going to do here. We're going to add a little degree of difficulty to it. We've already seen this material. Here's what we're going to do. Here's what we want to do. We're going to balance the load a little bit. We want router 3 to continue to use 172.12.13.1 as the next hop for traffic headed for 4444. But we want to change the metric 172.12.23.2 to be the next hop for the network 44. I'll start saying network 4 and network 44. It's a lot easier on your ears than hearing all those 4s. So if we want router 3 to go through router 1 to reach network 4, we're going to set a MED advertisement for both routers just for fun. We're going to have router 1 advertise a MED of 100 for that route, while 2 advertises a MED of 200. The lowest MED is going to be preferred. Now we're going to do the reverse or the inverse for the other path, and what we're going to do there is have router 2 advertise a MED of 100 for network 44, while having router 1 advertise a MED of 200 for that same network. That sounds like a lot of typing. It really isn't, but let's go ahead and bring the live equipment up. And we're going to start over on router 1. And the first thing we're going to do, you probably saw a little hint of it on the bottom of the screen, we're going to start with some access lists because we have to identify the networks that our route maps are going to refer to. So we'll just make it even more intuitive than usual and make that a permit 4444. And then I'll write an access list 44 for the other one. So far, so good. Now I'm going to write a route map. And if this is your first time seeing route maps, the logic is very simple. You've probably seen them before, but you call it something intuitive. You know, don't call it Fred or Sam unless you really want to. Let's go ahead and call it set med. And then you've got your permit or denies. And I'm going to go ahead and give it a sequence number here of 10. And I want any route that matches access list 4. And that's where I need to go with IP address. So it's match IP address 4, and that number refers to the access list. And any or the route that matches that, I want to set a MED of 100. Now, there's only one problem here. Being a master of the alphabet, I can see that there's a metric and a metric type, but I don't see anything here about a multi-exit discriminator or a MED. And that's why you got to know that this metric they're referring to right here, that is the MED. It's not a great metric value for destination routing protocol. That's a pretty generic description, but we're going to go with that, and we're going to set it to 100. Now I'm going to set another clause of the route map, same one, permit 20, and if it matches IP address 44, I want to set a metric of 200. So that's what we decided to do on router 1. Now let's go over to router 2. We're going to write the exact same 2 access lists. We couldn't just copy and paste because of course the route map is going to be a little bit different. I'm going to use the same name, permit 10, and now if it matches the IP address identified by ACL 4 here, I want to set a metric of 200. Route map 20, match IP address 44, set metric 100. So far, so good. I've got my ACLs written, I've got my route maps written, everything's looking good, and there's something else I need to do with these. Apply them, that's it. Let's go under our BGP config. And let's look for our route map entry. And it would seem again we don't exactly have a route map entry here. That's another thing we got to know. We got to know that the metric in the other list refers to the MED. And with route maps and BGP, we're going to apply these with the neighbor command. So it's 172.12.23.3 and not quite there. There's our route map right there. We're going to be using the neighbor command a lot in the rest of the labs, but this is, you're going to use neighbor a lot, period. So we've got the route map entry. Now we need to put set med, and you've always got to say, of course, with a route map, you know, incoming routes or outbound routes, what are you going to apply it to? And we're applying it to the outbound routes. Put much the same command over here on router 1. Of course, the IP address will be different for the neighbor. So 2.12.13.3, route map set med out. Now this does not count as a routing update. So we need to do a little clearing here. We're going to do a soft one. Oops, clear IPBGP. I knew that asterisk was up there somewhere. Out. So let's go over to router 3 after all this and see what we see. And you can see that one of the choices has changed. And also note now that we actually have values under metric. We don't have any values under LOCPER for local pref. We know that's a default of 100. That's just an oddity of the show IPBGP command. But with the metric where we didn't have anything before, now we do. And note that the metric on router 3, it's seeing a MED of 100 for network 4 with a next hop of 13.1, and it's seeing a MED of 100 for network 44 with a next hop 23.2. So now we're doing a little bit of balancing. We've got a much better situation going on than just sending it all over one link. But you can see, again, and let me run the detail command there for you. You can see how the MED really comes in handy. Because what if we had 50 routes? You know, maybe we want to take 25 of them, run them one way, 25, run them the other way, instead of running them all over the same path. Whoops. 4444 is what I meant to say. And you can see there's the metric now. We didn't have that before, and that is your MED. So a lot going on here with the MED. The first time or two you set it, you know, a little extra planning, you got to write your ACLs, got to write your route map, then apply it, then do a soft reset. But you can see this is a fantastic attribute to use when you've got a couple of paths you want to use, but by default, of course, only one of them would end up being used. Coming up next, I think it's time we took a look at that LOCPER, that local preference, and see what's going on with that. That's coming up next.